This is a DC high voltage generator, commonly known as a high voltage package. This little thing can convert a few volts of input into tens of thousands of volts of output, cut off the outer shell wire, use a hot air gun to heat it closely to soften it, and then add steam and capacitors to its voltage, leaving only the transformer. Now the output voltage is only a few thousand volts, which is safer and very suitable for making plasma lighters. The lathe processes round tubes to make the lighter shell. The lathe is of appropriate size, and then a section of aluminum tube is blown to fix the battery. I found out after disassembly. This tube itself was a bit too narrow, so when I put it in, it was a bit wobbly, and didn't fit perfectly. I had no choice but to use a knurling tool to process it a bit. The pattern doesn't have to be perfect, it's not a big deal. It just needs to fit in there for a test. See, it's a bit tighter now. Yeah, it really works. I have to push hard to get it in at the end. Done. It's perfect. Cut with a paper and ink machine. And make the positive terminal of the single-sided copper-clad board to connect to the battery. Reposition it so that the electricity flows out properly. I'll turn it in the chuck, using coarse sandpaper to grind it into a round shape, and then I'll solder a wire to the back. The spring from the copper-clad surface was taken from a flashlight, and I'll add a layer of gasket, securing it with 502 adhesive. It's already installed. I added the battery compartment on this side, and the other end is for installing the transformer. The exposed end of the green wire is connected directly to the metal shell. The bakelite board is glued to the steel pipe, to make it easier to process the outer diameter on the lathe, ensuring it fits properly at 10 inches. Then smooth the cross-section, and check if it fits. Well, exactly. 80.5. Cross-section wash basin groove is used to install the switch side to connect with it. Next, I'll make two very small output holes to clear out the switch and install it into the groove we just processed. The contact point only sticks out a tiny bit. See, it's really easy to press down, not difficult at all. Once the module is in, it fits snugly. And we can connect the two output levels. The positive input is controlled by a small switch, which releases a piece for installing the metal discharge head. The discharge head is made from a stainless steel rod. By turning and grinding like this, you can avoid using a lathe. Small copper pieces, position them properly. Make holes, shape them into two teardrop forms, then solder them with tin, and attach them to the discharge head. Polish the welding spots, smooth for a better appearance. Remove the copper plate to make the mast. Its outer diameter matches the inner diameter of the casing. Use a center drill to penetrate this disc, making the outer diameter slightly larger. Use a cutting disc to release and cut it open. Then continue to widen the cut with a file, and use pliers to bend it into a slope. After shaping it like this, paint the inner side of the back cover with a red lacquered piece. Similarly, apply lacquer well, heat it with a torch, and weld them into a three-dimensional shape. Powered by a lithium battery. It's the same battery taken from a flashlight. Insert it and take a look. The effect is quite good, right? The design is just right. This mass structure is like an expansion bolt. When the screw is turned, the spacer in the middle expands and presses against the outer shell, preventing it from falling off. And the back cover is also secured. I tested it, and the discharge head fluctuates normally, with no issues at all. To prevent it from feeling cold to the touch in winter, you can wrap it like this. By gluing the handmade rope together, the plasma arc lighter is completed. The arc is thin, but quite powerful. It can directly melt some small metal wires. This small steel wire brush is the same. As you can see, it's more than enough for lighting fires, and it has very low power consumption. A single charge lasts for about a month. Moreover, this little gadget can not only be used for lighting fires, but when aimed at an incandescent bulb, you can see more plasma inside, just like a plasma ball. It's quite interesting and fun. It's even more entertaining with this type of energy-saving lamp. Give it a bit of an arc. See? It can light up directly. Can we test it on the outside of the tube? Oh, that's not the right type. There it is. It's still better when aimed inside. The brightness is quite good, and it's more than enough for emergency lighting in special situations.